Homework 13, measures of average, video 6. Our last concept, but not our last video, is calculating the mean for data that's already been grouped. Unlike the previous videos, I'm not just going to come out and say, here's how to calculate it. I'd like to intuitively develop a plan for calculating it, come up with a formula, and then in the final video after this one, we'll apply that formula to another example. So here's the scenario. 40 cars were tested for fuel efficiency. Let me make sure these add up to give 40. 6 and 13 is 19, plus 8 is 27, plus 3 is 30, plus 10 is 40. Here are the grouped results. On the left, we have the miles per gallon to measure the fuel efficiency, grouped in values with a class width of 5. I can tell because 5 is how much you add to get from one lower limit to the next. So for example, 5 of the cars tested had a fuel efficiency between 8 miles per gallon and 12 miles per gallon. Only 1 car tested had a fuel efficiency between 13 miles per gallon and 17 miles per gallon, and so on. And we're going to estimate the mean fuel efficiency. And notice I said estimate. In the homework, they may actually say calculate, but honestly, it's just an estimation, and here's why. You know how to average numbers, and you know how to average 40 numbers. You add them all up, and you divide by 40. But what numbers are we going to add up here? When you filter raw data into classes, it's convenient in the sense that you only have fewer classes to look at, but you lose the precision of the measurements. For example, when I said 5 of the cars had a fuel efficiency between 8 and 12 miles per gallon, I don't know what those individual cars' fuel efficiencies were. Were all of them 8 miles per gallon? Were all of them 12 miles per gallon? Were 2 of them 9 miles per gallon and 3 of them 10 miles per gallon? We don't know. That's the problem with filtering raw data into classes, is that you lose the specificity of all of the individual measurements. Well, that's a problem, because to calculate the mean, I'm supposed to add up all those individual measurements, and I don't know what they are. I don't know what the 5 values in this range were. I just know they were between 8 and 12. I don't know what the 1 value in this class is. It's either 13, 14, 15, 16, or 17. Assuming we're not using decimals, which I don't think we are because there are no decimals here. So it's technically impossible without more information to exactly calculate the mean, because I don't know exactly the 5 values in here, the 1 value in here, the 13 values in here, the 8 values in here, the 3 values in here, and the 10 values in there. So what do? Well, the best we can do is to come up with an estimate for the mean. And the way we come up with an estimate for the mean is we need to come up with a best guess for what a value in this range would be. For example, if I said between 8 and 12, so 8, 9, 10, 11, 12, which of these would be a best guess for the value in this interval? You might be thinking, well, they're all equally likely, aren't they? Well, sort of. But we have to pick one, and guess which one we're going to pick? I wouldn't pick 8 because that's lower than all of them. So anything that was greater than 8 was underestimated. I wouldn't pick 12 because it's greater than all of them. So what should I pick? 10? 10's greater than some of them, less than some of them, and equal to the one in the middle. So yeah, here's the strategy that we're going to play out. Because we can't recover the original 5 values in here, we're going to assume that they are all the best guess. And what is the best guess? The best guess is the midpoint of each class. Midpoint of each class. So I don't know what the 5 numbers between 8 and 12 were, so I'm going to guess that they're the number that was in the middle. And remember, the formula for midpoint is to average the lower limit and the upper limit, like when we were making polygons. So 8 plus 12 is 20, 20 divided by 2 is 10. That makes no sense. It's the number that was in the middle. And we could do the same thing for the rest of them. I don't know what the one number in the second class was, so I'm going to make a best guess by finding the midpoint by averaging 13 and 17. If we add 13 plus 17 and divide it by 2, we get 30 divided by 2, which is 15. And it won't take you long to pick up on the pattern in the midpoints. 10, 15, I'm predicting the next one will be 20. If we find the midpoint of the third class, 18 plus 22 divided by 2 is exactly 20. In math, it's bad to say that 3 examples prove something. They don't ever. But for our purposes and at this level, we can just assume that this pattern would continue. 10, 15, 20, 25, 30, and 35. So here's what this means. We don't know what the 5 numbers are in this class. We're going to assume all of them were 10. They probably weren't. But our best guess for one number is the number in the middle. And so our best guess for all of the numbers is the number in the middle. So we have to imagine that we are now going to average 5 of these, 1 of these, 13 of these, 8 of these, 3 of those, and 10 of these. More specifically, that we're going to average 5 10s, 1 15, 13 20s, 8 25s, 3 30s, and 10 35s. So, could we do that? Of course we could. Is it cumbersome? Of course it is. We're assuming all 5 numbers in here were 10s, so we're going to write the number 10 5 times. In the second class, we're assuming the one number in there was the midpoint, so 115. And then, oh great googly moogly. I wonder how YouTube auto caption's going to do there. In this next class, we're assuming all 13 numbers are 20s. So does that mean I need to write the number 20 13 times? Well, if this is the approach you're taking, yes. But wait a second. We're a little more sophisticated than this. There's a shorter way to figure out what you get when you add 20 13 times. And that's to do 13 times 20. So although this approach isn't wrong, we're just averaging a bunch of numbers. Some of the numbers we're adding are repeating over and over again. Like these 5 10s. I didn't have to write 10 5 times. I could have just written 5 times 10. So let's take this idea and make it a little bit more efficient. We are going to multiply this 10 by 5 because we're adding up 10 5 times. So 5 10s plus 1 15. I know 1 times 15 is 15, but I want to keep the frequencies in the formula. We're going to add up 20 13 times. We're going to add 25 8 times. I need to write this a little smaller. We're going to add 5 of the 10s, 1 of the 15s, 13 of the 20s, 8 of the 25s, 3 of the 30s, still going to run out of room, and 10 of the 35s. Give me 1 second, I'm going to check the window on my camera, and if that's off the window, I'm going to move the camera a little. It's barely in there. Okay. All right, so that's how we can easily add up all of our guesses by not adding this 5 times and this once and this 13 times, but by multiplying each midpoint times its frequency. Oh, but we're averaging, so we have to divide by something. How many cars did we measure for fuel efficiency? 6? There are 6 classes. But no, there were not 6 cars. There were more than 6 cars here. Oh wait, it said right there 40 cars. So there were 40 numbers that we're averaging, so we're going to divide by 40. But let's say for a moment that instead of 40, it said some cars, and they didn't tell us how many there were. Some cars were tested for fuel efficiency. Here are the grouped results. How can we recover the number of cars that were analyzed? Well, earlier I checked, these added up to 40. So really, to get the number that we divide by, if they don't tell us, there's still enough information in here. We know that there were 5 cars in the first group, 1 in the second, 13 in the third, 8 in the fourth, 3 in the fifth, and 10 in the sixth. So if we weren't told how many cars there were, we could actually just take the sum of the frequencies. And that would tell us how many cars there are. Okay, so I think we got everything that we need. I know the sum of the frequencies is 40. I'm going to spare us the trouble of calculating the numerator. I'll just do it in my calculator. Let's see. 965. Let me do it again and make sure I didn't make a mistake. I'm actually just adding the products, so 50 plus 15 plus 260 plus 200 plus 900 plus 350. I got a different value that time. Try it again. 5 times 10 is 50, plus 1 times 15 is 15, plus 13 times 20 is 260, plus 8 times 25 is 200, plus 3 times 30 is 90, not 900, plus 35 times 10 is 350. I got 965. And if we divide that by 40, we get a mean miles per gallon of 24.125. So that's the best estimate we can come up with for the average of the 40 numbers that we don't know individually, but rather that 5 are in this class, 1 are in this class, 13 are in that class. 8 are in the 4th class, 3 are in the 5th class, 10 are in the 6th class. We just multiply each class's midpoint times its frequency to add them more efficiently. Take the sum of all those products, and then we divide it by the sum of the frequencies. This sounds like something we need to turn into a formula. Let's do that in the next video.